Hello everyone, this is Chinnaiah Kalpana here. In this video, we are going to solve a differential equation from higher order linear differential equation with variable equations using reduction of order method. So let's get going. Problem. Solve d square y by dx square plus y equal to secant x or y double dash plus y equals to secant x using reduction of order method. Given that y equal to cos x is a part of complementary function. So we are given a differential equation d square y by dx square plus y equal to secant x, or we can write d square y by dx square as y double dash. So we'll get y double dash plus y equals to secant x, and we are given a part of CF of this equation. Okay, consider it as equation 1. Now compare 1 with the standard form y double dash, standard form of second order linear differential equation, y double dash plus py dash plus qy equal to r. By comparing these two, we'll get p, q and r. We have p equal to 1, we don't have any term involving y dash, right? So p equals to 0. And compare y with qy, q equal to 1 and r equal to secant x. Here we don't need to find the part of CF of 1 because we are already given y equal to cos x is a part of CF. Therefore, y equal to cos x is a part of CF of 1, which is given. Right? Where u equal to cos x, if u equal to cos x, derivative of u with respect to x is minus sin x. Right? If u equal to cos x, just differentiate on both sides with respect to x. We'll get du by dx, which is equals to derivative of cos x with respect to x is minus sin x. Okay, let y equal to uv be the general solution of 1. Already we are having u, which is cos x, but we need to find v. Then v is given by the equation d square v by dx square plus p plus 2 by u into du by dx into dv by dx equal to r by u. Consider it as equation number 2. Okay, now substitute p, u, du by dx, r and u in this equation. This equation becomes d square v by dx square plus p 0 plus 2 by u into derivative of u with respect to x, which is minus sin x, into dv by dx equal to r secant x by u cos x. Right? Then this becomes d square v by dx square plus into minus 2 into sin x by cos x into dv by dx equal to secant x into, we can write secant x by cos x as secant x into 1 by cos x. Then this becomes d square v by dx square plus into minus 2 into sin x by cos x is tan x into dv by dx equal to secant x into reciprocal of cos x is secant x. Right? then d square v by dx square minus 2 tan x into dv by dx equal to secant square x. Let dv by dx equals to capital V, then d square v by dx square will be d capital V by dx. Now the above equation becomes, simply replace d square v by dx square with d capital V by dx and dv by dx with capital V. Then we'll get dv by dx minus 2 tan x into capital V equal to secant square x, which is linear in capital V and x. Consider the above equation as equation number 3. Let's now find the solution of this equation. Okay. Now compare this equation with the standard form of linear differential equation, which is in v and x, dv by dx plus p1v equal to q1, say. Now by comparing these two, we'll get p1 equal to minus 2 tan x and q1 equal to secant square x. So now we need to find integral p1 dx and integrating factor, which is given by e power integral p1 dx, and later we'll find the solution of this equation using v into integrating factor equal to integral q1 into differential dx plus c1. Okay. So we'll begin with integral p1 dx, which is equals to integral p1 minus 2 tan x into dx is equals to minus 2 integral tan x dx. Since we know that integral tan theta d theta equal to log secant theta. If you're not that good at remembering the formulae, you can just write tan theta as sin theta by cos theta. Let f of theta equals to cos theta, then f dash of theta will be minus sin theta, right? So here we can apply the formula integral f dash of theta by f of theta into d theta, which is equals to log mod f of theta, right? But here we are having sin theta in the numerator, but we need minus sin theta. So what we'll do is we'll just multiply, minus into minus, because minus into minus is plus, right? Minus into minus is plus. Okay, this equals to minus integral minus sin theta, which is f dash of theta, cos theta, which is f of theta. So we are having minus integral f dash of theta by f of theta into d theta, which is equals to minus integral f dash of theta into f of theta d theta is log mod f of theta. Now replace f of theta. Here f of theta is cos theta, right? Or we can write it as minus log cos theta. Since we know that m log n can be written as log n power m, then we can write minus log cos theta as log cos theta whole inverse. Okay, so we got log cos theta whole inverse, right? Then integral tan theta d theta equal to log cos theta whole inverse can be written as 1 by cos theta. We know that reciprocal of cos theta is secant theta, so we'll get log secant theta. Okay. Then integral p1 dx equals to minus 2 into integral tan x dx is log secant x. Okay, or we can write it as log secant x whole square, since m log n equal to log n power m. Okay, which is equals to minus log secant square x. Again here you are having minus log secant square x. Again by applying this we'll get log secant square x whole inverse, which is equals to log 1 by secant square x. Okay. Now find integrating factor using e power integral p1 dx, which is equals to e power integral p1 dx is log of 1 by secant square x. Since we know that e power log some function of x equals to function of x, right? Then we'll get 1 by secant square x. So we got integrating factor 1 by secant square x. Let's now apply this formula to find the solution of equation 3. V into integrating factor equal to integral q1 into, here you will get integrating factor into dx plus c1 into integrating factor into dx plus c1. Okay, we are using v into integrating factor equal to integral q1 into integrating factor into dx plus c1 formula. So this becomes, here secant square x gets cancelled and you will get integral dx plus c1, which is equals to x plus c1. Now take this term to RHS, then we will get v equal to x plus c1 into secant square x, which is equals to x secant square x plus c1 into secant square x. Since capital V equals to dv by dx, let's replace capital V with dv by dx. Let's now separate the variables. In order to separate the variables, we have to take differential dx to RHS, then we'll get dv equal to x secant square x plus c1 secant square x into dx. Then dv equal to x secant square x dx plus c1 secant square x dx. Okay, here the variables are separable. Let's now perform integration. Integral dv equal to integral x secant square x dx plus c1 integral secant square x dx plus integral constant says c2. Let's now find this integral separately. So the integrand is of product of polynomial function into trigonometric function, right? Let's consider x as u, that is polynomial function as u, and the remaining part as dv. Now we need to apply integration by parts formula. Integral u dv equal to uv minus integral v du. So we are having u equal to x and dv equal to secant square x dx. Differentiate on both sides with respect to x. We'll get du by dx equals to derivative of x with respect to x is 1. From this we'll get du equal to dx. Here integrate on both sides. We'll get v equal to integral secant square x dx is tan x, right? Now apply this formula. Integral u into dv is equals to uv x tan x minus integral tan x du equals to dx. This is equals to x tan x minus log secant x. So the result obtained from this integral is x tan x minus log secant x. Now coming to integral dv, we'll get integral dv v equals to integrate secant square x dx is x tan x minus log secant x plus c1 into integral secant square x dx is tan x plus integral constant c2, right? We got v and already we have u, which is cos x. Let's now find the general solution. Therefore, the general solution is given by y equal to u into v, x tan x minus log secant x plus c1 tan x plus c2 is equals to x tan x into cos x minus cos x into log secant x plus c1 tan x into cos x plus c2 cos x. Since tan theta equal to sin theta by cos theta, so we can replace tan x with sin theta by cos theta. Then we'll get x into sin theta by cos theta into cos x, right? Sin x by cos x into cos x minus cos x log secant x plus c1 into replace tan x with sin x by cos x into cos x plus c2 cos x, right? Cos x gets cancelled. Then we'll get y equal to x sin x minus cos x log secant x plus c1 sin x plus c2 cos x. Or y equal to, write the terms involving c1 and c2 first. c1 sin x plus c2 cos x plus x sin x minus cos x log secant x. So this completes the problem. Let's now see that y equal to cos x is the solution of homogeneous equation of y double dash plus y equals to secant x or not. Okay. This is the verification part. If we have any doubt that y is cos x, y equal to cos x is solution of homogeneous equation of y double dash plus y equals to secant x, or y equal to cos x is a part of CF of the non-homogeneous equation or not. Okay. So we are having y equal to cos x. We are going to verify it. Then y dash equals to derivative of cos x is minus sin x. Then y double dash is derivative of sin x is cos x, right? And the homogeneous of this equation is y double dash plus y equals to 0, right? Now we are going to see whether y equal to cos x is solution of this equation or not. If y equals to cos x is solution of this equation, then we can say that y equal to cos x is a part of complementary function of this equation also. Okay. Now consider the LHS part, y double dash plus y. Now substitute y double dash and y. We have y double dash minus cos x and y is cos x. right? We took LHS part of homogeneous equation. So now minus cos x plus cos x is 0, which is the RHS part, 0. So we can say that y equal to cos x, consider this equation as some asterisk. Y equal to cos x satisfies asterisk. So therefore y equal to cos x is the solution of asterisk, or consider this equation as some equation 4. Oh, this is equation 1, right? We have named it as equation 1 earlier. Therefore, or y equal to cos x is the part of CF of 1. The verification part is not in the solution, okay? Here itself it completes. So we have seen a problem from reduction of order method, including verification part in this video. Hope you'll understand. We'll see you in the next video. Until then, bye bye.